has recently joined the newly formed Wadhwani Institute of Artificial Intelligence as its CEO. Previous to this, Anandan was VP for Research at the Adobe Research Lab, India, and before that, a distinguished scientist and managing director at Microsoft Research. He was the founding director of Microsoft Research India, which he ran from 2005 to 14. Prior to this, Anandan was a researcher at Sarnoff Corporation and an assistant professor of computer science at Yale University. His primary research area is computer vision, where he is well known for his fundamental and lasting contributions to the problem of visual motion analysis. He received his PhD in computer science from University of Massachusetts, Amherst in 1987, a master's in computer science from University of Nebraska, and his BTech in electrical engineering from IIT Madras. He is a distinguished alumnus of IIT Madras, UMass, Amherst, and is on the Nebraska Hall of Computing. Now I'd like to invite Dr. P. Anandan to address the crowd.
Now, before I start talking about the topic, right, first of all, I was expecting a smaller crowd and a talk. So now Ravi told me that I had to be more entertaining. Unfortunately, my slides are not going to be entertaining, so I'll try to be. How many of you are, say, BTech students? A handful. And CS majors or something else? Okay. And MTech, MS, whatever, and PhD? About roughly equal number. That's actually interesting. So, back when I visited IIT in the past, and I've been doing this for 15 years or so, you always see almost zero hand raises when it comes to PhD students, and then, majority of BTech and so on. So it's good to see that the mixture has changed. I guess the question I'll start asking you is artificial intelligence, right? This is, of course, now the buzzword, and, I guess it's now what used to be IT or software engineering about 15 years ago or something like that. Like 15 years ago, if you wanted to be on top of things, you would learn to be an IT professional or software engineer, and now you have to be, you have to do something in AI. So, broadly, how many of you know or have taken a course in artificial intelligence or something related to that? It's interesting. Not everybody, I would have thought. So this half of this segment has not even ever taken a course in AI, right? But do you know what artificial intelligence is? What does it mean? Sorry? Yeah, that's the ultimate goal, right? So what do you think? Why do you think AI has become so popular recently? What do you think is the thing that triggered it? Any idea? Sorry? Where are you? What did you say? AlphaGo. That's not a bad answer, but anything else? How many of you know what AlphaGo is? So this group of people don't know much about AlphaGo, right? So in fact, AI as a field has been around for 1950 something, right? So about 60 years. And the field started, actually the name was given at a conference that happened in the late 50s. At a place called Dartmouth, which is in the northeastern part of the United States. And the term was coined at that conference as a new discipline in order to create computing technology or computers that would, as someone here said, mimic the capabilities of the human mind. So very ambitious goal. And a lot of us who were drawn into it, like I did my PhD specifically because I wanted to solve the problem of how the human mind works and believed that this is the best approach to understand how the human mind, regardless of its application in terms of technology and so on, the concept of being able to understand how the mind works is always very appealing, right? Now today, there's probably a certain amount of belief, thanks to AlphaGo, that we have computers that actually imitate the human mind, but that's actually not true. The capacity of computers today to do artificial intelligence is way much more limited than the capacity of the human mind. So there's no risk, in the immediate future of these machines becoming more capable than the humans overall. However, in particular domains, they are actually more capable than humans. So AlphaGo being an example. For those of you who don't know, AlphaGo is Go is a game, which is like a board game. Do you know the game Go? I've never played it. So it's like a, it looks like a chessboard, but it has these pieces that, two opponents play. I've never played it, so I don't know how it works. However, apparently it's more complex than chess, from what I understand. And there is a company based in UK called DeepMind. You should go look it up. Who demonstrated that their program, trained through techniques in artificial intelligence, can actually beat the world champion in Go. And that program is called AlphaGo, right? Now, AlphaGo program uses a technique. I'm going to let you in on a secret now. After this, you'll all be crowding to the front of this room. AlphaGo uses a technique called deep reinforcement learning. And one of world's experts in deep reinforcement learning is sitting right there in the front row. So you should go talk to him. He's a professor here in computer science. Now, the word reinforcement learning, right? So the word learning, that's probably more important. See, AI has been around and we've all made attempts to build AI systems. Back in the 1960s and 70s, there used to be, 60s I think, there used to be a program called ELIZA, which was like a talking AI systems. You would ask a question and it would answer that question, but it actually tried to it's like a psychological counselor program. It turned out very convincing for a lot of people that this is doing something, there's an intelligent being behind it, but it was an extremely simple algorithm that simply read your question and turned it around into some kind of an answer without knowing a lot of stuff. But it kept people engaged. And they believed that they found, had a machine that was intelligent. So, but some time went by, people discovered the weaknesses in that approach, and it kind of died down. But sometime later, by about, say, the beginning or the middle of 70s, there used to be programs, there was a couple of programs called Mycin and Dendrol, which are medical diagnostic systems, where it'll ask you a bunch of questions about, your condition or whatever, and try to diagnose what could be your ailment. And that was actually quite a popular, not practical program, because it turned out that the capacity to build such a program at a scale to answer all the questions was beyond our reach. In other words, it would do well in a certain number of circumstances, but it wouldn't generalize automatically, and it wouldn't, more importantly, learn from anything that it did. In other words, as a person who's creating the system, you can build the system, put a bunch of rules, and it'll use those rules to answer questions, when patients came and talked to it, or in those cases, they typed the whatever in some kind of a teletype. This was before, you must remember, cathode ray tubes and so on, so they were actually typing on a typewriter kind of a machine. It would answer questions. However, after you go away, it never retained anything that you did. So when the next person came and asked the question, it didn't actually learn anything from your interaction. So everything had to be programmed in. And so back in those days, artificial intelligence systems did not have the capacity of learning. They were simply very complex reasoning systems, and they were fairly sophisticated. I used to make a joke when I was first professor of AI, this was in Yale after my PhD. The size of an AI program in terms of the number of bits or byte size or whatever was usually significantly larger than the amount of information it contained during its entire lifetime, because you could literally write down the answers if you want. But there was a lot of optimism about that generation of systems, and they were called rule-based systems or expert systems. So back, if you had all been 30 years older, you would have been very excited about rule-based systems and expert systems. And this was the theme of the day, for example, when I did my PhD in computer vision and artificial intelligence. So this kind of come to around the 80s. People realized that these systems are over-bloated and they were not capable of the kind of general usage that you want to do. So their popularity started dying down. So for me, actually, just about the time I finished my PhD, a new domain of artificial intelligence systems were beginning to become popular, and they were called neural networks. How many of you have heard the term neural networks? Not that side, this side. Because that side, I think you guys know everything. So this side. Okay. So interestingly, the original sort of idea behind artificial intelligence systems goes back to even before the 50s, like 40s or 1940s or so. And they were based on an idea called neural networks. Neural networks were quite simple. Basically, the idea was that with the limited understanding about the human brain, the scientists believed that the brain is made up of these simple units. There'll be a node, and which will be triggered by input from a bunch of other nodes, and it'll analyze the input, and then it'll turn on or off. It had only two possible reactions. It can be on or off, and whenever it's on, its signal would go to the next node, and so on and so on. So it's a large network. So that's how our brain is made. It's a collection of cells that are connected to each other, which trigger each other, and each cell looks at its input, does some simple arithmetic, and then it turns on or off, right? So this was, this is actually still not a very completely bad understanding, although it's, kind of oversimplistic. And, a number of researchers began to play with networks of this nature. They would build networks, that are based on these kind of properties, and they'd put it together, try to solve various problems. And, this neural network strand would come and go in the research domain. And back in the 80s, it came up again as a popular kind of a thing. And in particular, there were two people, a professor in Toronto, I think Carnegie Mellon maybe, called Jeffrey Hinton, who showed some interesting behavior with neural networks. And another person in, I think it was at Lucent Bell Labs, called Jan LeCun, who did the most practical thing, showing that he can create a neural network system that would recognize digits on a paper. So he was funded by the US Postal Service, and they wanted automatic recognition of zip codes or PIN codes so that they can do the sorting. So they paid him, research funding for that, and he actually built a digit recognition system, which all it had to do was to, recognize 10 digits, 0 to 9. And it was very, very successful, and it worked. But people believed that that approach would work only in limited, situations. 9, 10 digits, that's an easy problem, right? But the core idea behind the way that he did it was that the system would learn from examples. You don't have to build in the rules for the system to, know how to do this. So in other words, what you do is the system will be kind of raw. You'll have a bunch of these nodes connected to each other, and initially they weren't doing anything. But you will show it input, meaning you'll show these digits, and usually in a pixelated form, in some binary representations or whatever. And output would come, and it would recognize the digit or not. If it recognized the digit, you would give it a reward saying, well, that's very good. If it failed, you would say, no, that's not very good. And then he had a mechanism for taking that feedback and propagating it back through the network. So all the nodes in the network would adjust themselves in some way to do more of that. So if it got positive feedback, the network would try to do more of that. Got negative feedback, it would try to do less of that. That was a very, very simple idea, and the entire network learned by, getting feedback propagated all the way back. It turned out that that approach, when done properly, was able to actually solve the problem. So there was a big breakthrough here in that you don't have to actually build these rules, hand code them and things like that, but you can actually just let the machine, a simple machine, look at data, and from that data and sort of a teacher, you're telling him good, bad, it would learn actually to do the correct thing. But unfortunately, when you try to apply that approach to larger problems, it did not work so well. So when you wanted to recognize a human face, for example, who are you? Or you want to recognize whether it's a chair or a table or a desk, it wasn't doing so well. And my domain, is computer vision, so I was quite familiar with all of this that was going on, right? So after about, 1980, 1990, there was a lot of excitement about neural networks. There was a conference called Neural Information Processing Systems that was started at that time. It was very popular for a few years, and then the field kind of sunk once again. So the AI has this habit of having these peaks and valleys. I think it's very seasonal. AI has springs, summers, and winters. Right now, we are enjoying the most glorious AI summer that I think, we ever have. But there's a reason for that. And as an optimist, I'm going to believe that this time the summer will last forever. That's like believing corruption is gone in India or something, but we'll do that anyway. So, but there was a class of machine learning techniques that came up at that time. So I'm already using the term machine learning, so keep that in mind. So these are similar to neural nets, but a little bit different. They require more engineering than the kind of neural nets that I talked about, but not as much as building in rules. I'm not going to explain to you the details. You can take a course from Ravindran or somebody else for that. And they were called support vector machines, for example. Don't worry about what the word support vector machines, and later on they became broadly called kernel machines. And these things actually did reasonably well. For a decade or so, from the, say, mid-90s to the mid-2000s, This was the dominant paradigm in artificial intelligence and machine learning. The old-fashioned rule-based systems were not very popular. People who are doing that kind of work were not very popular, but all of a sudden, people who are doing kernel machines and machine learning became popular. But they would perform reasonably well. For example, in an image recognition task, let's say we have a test data set. We have a test set of saying, I have 10,000 images, and I have 100 different kind of objects in those images, and I'll give you these images. You need to recognize the object, and if you get correctly, you'll get 1 point, otherwise 0 points. What's the percentage of score that you would get? And the algorithms of that time grow up to maybe 50-60% success, right? So you would get 60% of the time, you would get the right answer, 40% of the time, you would get wrong answer. Likewise, in speech recognition, right? When you're trying to learn, say English, keep it simple for the moment, because a lot of the work was in English speech recognition. The speech recognition systems go up to about 80% success. 80% of the time, you can recognize what it says. Human performance, is a little bit above 90% actually. So it was like we could never break that barrier. For at least like a decade, we stagnated at 80% or 60% or whatever. And then around 2009, the first breakthrough, 2009, right? First breakthrough, this is the Hinton, the speech recognition thing, maybe 2010, I don't know. Around that time, the first big breakthrough in speech recognition showed up. All of a sudden, it was performing better than human performance, 4% error rates, 96% success. Back to the same neural network approaches that were successful in the digit recognition with lots of improvements and modifications and very good training methods. Most importantly, what had happened in that period is that we had collected a lot of data. We were not training it on 100 examples, 1,000 examples, or 10,000 examples, but millions of examples, right? Millions of test examples that you use to teach the machine. And we had huge computing power. These machines take a lot of computing. Now we can put it on, very fast computers, thanks to Moore's law, and we were getting results. Not same old, but similar techniques. And 2012, it's actually at a conference when Hinton announced this. The image recognition problem was also beginning to get solved, 90% success. And then suddenly everybody took notice, right? Now, in between this, something else had happened which many of you may not know. Do you remember having heard of IBM building something in AI that was very successful? Any of you remember this? Things get forgotten so quickly. Okay, there was Deep Blue chess machine. You're not supposed to say anything here, Professor. Sorry, you can't answer it. So IBM, created a machine or a system that won this quiz game that's popular in US television called Jeopardy. Have you heard of Jeopardy? It's a very interesting quiz game. My mother, when she lived in the US for a long time, would watch it every day. But it's a very popular game, and it's really hard to be top in that. And the humans that take part in it are really, really good. IBM showed its system was actually able to beat human performance. And the way it did it is by engineering and putting all the knowledge for all the questions that it could think of in a big database, and the machine could always find the answer. The important thing, though, is that the machine can find the answer in real time, really quick, and also it knew how to find the right answer through very complex sort of a search mechanism. So they did do that. But again, it was not a learning and evolving system. But then this thing came with the computer vision, and all of a sudden, literally, the current field, the current buzz in artificial intelligence is only about 5 years old. 2012 onwards, it exploded. All of a sudden, people realized that this method of training neural networks was very broadly applicable, right? Now, some of the applications. So you all must have heard about self-driving cars, right? Have you not? Okay. So self-driving cars, how do they work? They work because they have cameras and sometimes other sonar and other sensors that are looking at their environment to see what is out there. And if they see that there is potentially an obstacle in front of you, they'll give you a warning or something like that, and then you can do whatever. Or in the case of self-driving cars, the car would adjust its speed. Or if you're looking at lane changing, the mirrors would indicate that somebody is on your side, so don't change the lane right now, or whatever, right? I actually sat in a self-driving car and went about 60 miles one time about 3 years ago in Israel. And the entire time the driver did not touch the steering wheel once. But it was highway driving, which is relatively easier, I guess. I don't think self-driving cars are ready for India as far as I know, or at least Chennai or Bangalore. I mean, I think there is somebody who's doing it now, but my feeling is that they'll probably just come and sit there and, give up or something, right? Because most of the time we sit there anyway, so what's wrong with a self-driving car sitting there? However, they have been one of the big, drivers of AI technology. So you might have heard about it. And trust me, in about 10 years, when you are all ready to own your own cars, you won't have to drive it. This is I don't know if it'll happen in India, but it'll certainly happen. Because this is not really far away in terms of, real world deployment. That technology, and I talked to one of the founders of one of the companies that built this technology for self-driving cars. And he told me that he had built using these kernel machines or whatever, these technologies. And one day he ripped up all his backend and replaced them with these things called deep neural networks, which are doing deep learning. And he got 3 times as good performance. So he's completely switched his method of doing things. So and then people started finding it that wherever you applied, this type of method, as long as you had a lot of data and you could formulate the problem well, and you have enough computing power for learning, you are able to apply it in an amazing number of places. So today, machine learning, especially deep learning, is everywhere, and it keeps getting used. However, just to be careful, it's way short of what you might call as intelligence. The complexity of the reasoning that you will do just in the process of getting up from here, walking outside, getting a glass of water, going to the restroom, coming back, not running into anyone, saying hi to your friend, ignoring somebody who's not your friend, or scowling at the people you don't like, whatever you want to do, sitting down, this is not something we know how to do using any of these methods. Okay, so it's really far from general intelligence. But what we know is that there is a lot of information in the data associated with anything. Like, for instance, if you're thinking about self-driving cars, right? The data is that everything in the scene, the picture of the objects behind you, how fast they are moving, you don't have to detect them. You can measure the speed from the images, the sound information, noise, whatever you want to do, and you throw this machine at it. It will figure out which portions of this data are actually relevant. So for instance, recognizing faces. We used to build face detectors where we would say a face consists of 2 eyes here, which look like, slightly light area surrounded by something darker, and there is like a shape like this. We wrote rules like this, for recognizing faces. Deep learning comes, you don't do any rules, you put it in, it figures out what is important. It turns out what it figures out as important may not exactly be what you thought was important. And that's the key, right? The significance of what portions or information in your data that's actually relevant for the thing that you're trying to do is not as obvious as you think. If you try to write it down as a human, in fact, quite a lot of times you'll get it wrong. But the machines are ruthless. They won't, whenever they fail, they are punished. Whenever they succeed, they are rewarded. So they learn the right thing. And in many ways, that's probably how we learn also. We just don't know that that's how we learn, right? So it's great. So, when you're browsing through, all of you, I'm sure, have a Facebook account, even though the Russians are probably going to run all of it in the future. And all of you probably are doing search in Google. All of you are probably buying in Flipkart or Amazon. Or all of you are, watching Netflix or whatever. I use this thing called Wink for listening to Indian music, and I must say, the user interface is really bad. But all of these things are trying to guess what you'd be interested in, right? Before you do the next thing, they'll give you recommendations of what you might want. When you go to buy Amazon, it'll tell you 10 other things that you want. How do they do this? They do this because they understand from your behavior what you might be interested in by comparing your behavior to other people's behavior and what they would be interested in, right? So that's an example of artificial intelligence that you're seeing in everyday life. This is, the pace at which this is growing is very rapid. For example, today, the leading companies doing artificial intelligence would be Google, Facebook, Amazon, Microsoft, and probably Baidu in China. Then there are others, right? What that means is that between these companies, they are gobbling up anyone who has an artificial intelligence trained degree. So, if you're really interested in getting a good job, go study AI and you'll get a job in these companies or anywhere else, right? But why is it that they are able to do those kind of investments? Because at the end of the day, there's a large market of consumers like ourselves, right? Who are paying for it one way or the other through the clicks that we do on the things that we select, which eventually turn into advertisements that pay for it. You don't know you're paying for it, but you're paying for it. So there's a tremendous amount of investment in developing artificial intelligence technology in the mainstream. There is a lot of hype. It's not going to be as capable of human being, I don't believe, in the next decade or two. But it is going to be very useful. It's already been proving to be very useful in real world applications and commercial applications. So there's a lot of value in it. Now, data science, which is a slightly different term, and the reason I'm bringing it up is because you might have heard of it. How many of you know the term data science as opposed to, say, artificial intelligence? The primary difference between data science and AI, and I won't keep asking questions to you because it's a little disruptive, but so I'll say it, is that data science ultimately is preparing and analyzing reports from data, analyzing the data, preparing reports in order for a human to consume and to be able to make decisions. When you go one step further and make those decisions automated, you begin to get closer to artificial intelligence. They're not that different. In fact, the techniques that are used tend to be very, very similar. Today, machines can read what you write and understand what you're saying, translate it to another language or react to that. They can listen to you. They can understand what you're saying and react to that. They can, recognize any number of things and react to that. All this is, very rapidly happening. But here's the key, right? All of this is happening in the domain where there is a lot of consumers, where there's a lot of value, and there's a lot of money to be made. Now, the world consists of how many people? Like 7 billion people? I don't remember now. It's 7 or so, how much? 7.2 billion people as of today. And tomorrow it might be a little bit more. But, no more than probably about 2.5 billion of these people really are part of this rich economy. I mean, we are all part of it, so don't worry about it. But there are literally about 4 or 5 billion people who are not part of that, right? And they are the people that you see not only in India, but any country, if you go to the rural areas, villages, and so on. And there's not a lot of money there to be spent. So their benefit, or the benefit they receive from these technologies, is what I call trickle down. As soon as problems get solved in the mainstream, some version of that technology may get packaged and come down to them, and they may benefit in their lives through that technology. But their problems may not actually be completely fitting with the technology that they are receiving, and they're not getting directly addressed by the research and innovation that's happening, right? Because why? There's no money to be made, or not much money to be made, right? So this is not a wrong, technology has always been about that, right? Technology has always put its investments where there is a money to be made. It's never been about noble causes, but that's how the world works. So in this case, a large number of people are really, not able to get the benefit of this technology. Yet they have problems, right? So take, for example, a farmer in, say, a small place in Tanjavur or in Bihar, which is, I think, poorer, right, than Tanjavur. Generally, I think whenever in India I think about a poor place, I think about Bihar or Jharkhand. I hope none of you are from Bihar or Jharkhand, but anyway. But compare that with a rich farmer from Punjab, right? A rich farmer from Punjab has many acres of land and has various kinds of machines, probably as good as Western technology. If he makes a mistake on what to do, like in terms of what to plant or when to plant or how to irrigate, it's okay. He's got enough buffer. In one place he fails, another place he succeeds. He can diversify, But a small farmer in Tanjavur, there's 1 year it rains, another year it doesn't rain. 1 year we have, like this year, he makes a mistake anticipating, and because a lot of the times he doesn't know ahead of time what's going to happen. What about his soil conditions? He's actually, seriously screwed because he doesn't have the buffer. He doesn't have the buffer to recover from failures. Interestingly, that's where you would think technology should be able to help, right? To help them more precisely decide what they do. But that's where, we don't have the technology available. So there is a lot of need in terms of healthcare. You can think about, the lack of access, lack of diagnostics. The greatest limitation in, healthcare in poor places, in rural healthcare, is the lack of doctors, human resources, right? There are not enough people who go to these clinics and are spending time. And when they go, they might have to see, like literally, I went to a primary healthcare clinic in Rajasthan a few weeks ago, and they get 150 to 180 people one doctor has to see in a period of 4 hours, right? So that's like 40, 45 people in an hour. Now what is that? That's like 3 minutes or something for one person? How much can a doctor do in that period of time? But a lot of the problems that they come up with, if we understood, their background, their age, gender, what they, eat, where they are from, can often be actually, diagnosed relatively quickly to a small number of possible causes and things like that. But that technology is not available. So why am I coming to that? The purpose of what we are going to do is really to see how we can address this, right? So our vision is really to harness the power of AI. Now you all know what AI is, which is all these things that I said and more, hopefully. And to address societal challenges, really to help underserved communities. If you remove the or, it'll become undeserved communities, so just be careful. So underserved communities throughout the world. But one thing about India is that there is enough and plenty underserved people. There's always something to do. People like us don't have problem, finding problems to solve, actually. Now, I'll say more about the donors. This is not my idea. Dr. Romesh Wadhwani and Mr. Sunil Wadhwani, they are both entrepreneurs of Indian origin living in the US. Sunil is actually an alumnus of IIT Madras, a few years senior to me. It's their idea. They contacted me about doing this. And given what I've done with my life, and this seemed like a more interesting thing to do than anything else I was doing, so I said, okay, I'll come and do that. Okay. Now, what we want to do is really this, right? Because in order to do these things, you're going to have to start from, not from scratch, but you have to start from the definition of the problem and be able to address it rather than take something that you already have and throw at it, right? Do you know about the hammer and nail problem in innovation? Any of you, not all you old guys, young guys. What's the problem with hammer and nails? So research often has hammers, right? Researchers build hammers. And then they usually build a hammer and then they go around looking to see where the nail is. And regardless of whether the hammer fits the nail or not, they'll bang it. That's how we all work. Ravindran is a great hammer maker, for example. Right? So, however, the problem is that not every nail can be addressed by your hammer. So one of the things we want to do is to identify what the nails are and then try to custom build the hammers that will work for those problems, right? So we want to create innovative solutions that are specifically related to the kind of problems we will see in society. And of course, at the end of the day, you can do this. If you just put it in the lab, it's great, but you're not going to have the benefit. Now, we don't have an opportunity to make money because there's not a lot of money to be made. So the only way in which we can actually have motivation to be successful, like all of you, right? You all write exams and get 9.8 GPA or something. In my time, the 9.8 GPA was impossible. I think the topper in my batch was 8.31 or something. Maybe, I don't know what it was. What? Huh? GPA out of 9? No, it's out of 10. Sorry? LK made like 8.5 or something, right? He was the topper in our batch. 9.8, I don't understand. I think grade inflation anyway. But whatever. But, just like you, we want rewards. How do we measure rewards? Actually seeing our technology used in society. And, when you're a small organization, I'm not thinking about, hiring hundreds of people. It'll be like 50, 60 people of smart people, creative people. How do you achieve success? You have to achieve success by working with the people who know how to deploy your solutions in the field, especially in societal problems. You can't actually build the technology and put it on a website and every person in a village in Kumbakonam or Tanjavur will come and use it. It's not going to work that way. You're going to have to go there and put it in front of them. And the best people to do that are government agencies and non-governmental organizations. So we are going to work with them to get our solutions out, tested and deployed and so on, right? Now, there's another thing. We are a small group, but even in India, I know at least 4 or 5 places, this institute, IIT Bombay, IIT Delhi, IIT Hyderabad, and a few others who have a very strong artificial intelligence group. And many of these professors, and students actually, more than maybe professors, want to apply their efforts to do something to societal good. But that's not their day job. Their day job is to teach students, do research, train students and write papers and become famous researchers and so on, right? And be called the world's expert on deep reinforcement learning or whatever. That's their career. So one of the things we are hoping is that given that we will have actually a sustained way of engaging with societal organization, we can try to funnel the energies of people who are not necessarily part of our organization. And the last is, quite frankly, this model of an innovation center for social good doesn't actually exist anywhere in the world. So we are hoping, even if you are moderately successful, it will have an effect of getting more people to think, about this. And hopefully these people will think about it better than I do and do a better job or something like that. So So I think I kind of went through this, but to recap, our core jobs are really to do applied AI research. We'll work with these organizations to understand what the problems are, assess the needs, and work the solutions, and work with government and NGO that are, to do them with a scalable, feasible, and impactful. Those are going to be our criteria for doing these things. We're going to test the solutions by putting it out in the real world field and all that. Third is, of course, when we give these out to the NGOs, one of the things about NGOs is that not all of them are tech savvy. Many of them started by people who don't know technology at all. But many of them, even when they're technologists that started. So I have a friend who worked for me at Microsoft Research. His name is Rikin Gandhi. And he decided to do peer-to-peer knowledge sharing among farmers in villages. So he created a very simple technology based on recording lectures on smart, like cell phone kind of video, and sharing it between farmers. Initially, we thought we would send it over some email and internet, and we found out that there was no email access, so we had to burn DVDs and take them from villages to villages. And he did that. This was in 2006, 2007. And he went and he's a technology guy, but he went and worked very hard. And soon he realized that he had to spend all his time on the programmatics of how to manage, getting into the village, how to work with the district collector or whoever to give you the access to whatever. Today, he has 150 people working for him, is present in 10,000 villages across the world, touches 1.5 million farmers, and he gets foundation money of like $14 million a year. Right? Amazing success, but actually low-weight technology. And I talked to him, when I was thinking about it. So he would be a great partner for us. So there is a lot of people in this community who are hungry for technology. So, we're going to try to work with them. And the last is, of course, be a hub, like I already said. These are different partners. At this point, I think I'll be repeating myself. So, just skip over it. We're going to work with government agencies, academia, like you all. Of course, as I said, the money I have will take me to about 30% of the size that I want to do. But if I'm successful, I should be able to convince a lot of other donors and foundations to give us money to do more things. So quite a bit of fundraising. And we'll work with companies, who see opportunities to work with us. And of course, NGO partners. And this is kind of useful to think about. See, at the core of doing all of this is really a core set of foundational things we have to do. And I meant data sets. The power of artificial intelligence or machine learning today is really, at the heart of it is the power of rich amount of data. So think about it like a machine. Data is the oil, right? So the more you have it, the more you're able to teach the machines and learn the machines. So learn the machines. Now, every time you go on a website and do something, right? That's data that's being gathered by Amazon or Google or anybody, and a combination of that. I used to work at Adobe, and we were creating a platform for doing digital marketing, which we had like 2,000 or 3,000 enterprise customers. All the major companies you think about are actually our customers, and including companies like Flipkart and MGM and Disney and banks and all these. They're all our customers. They were using our platform. We used to get something like 3 trillion transactions a year on our platform. And that's the amount of data that we could use to learn and innovate technology. 3 trillion transactions. You go to rural, public healthcare, you're not going to get any transactions because we don't even know how to collect data. So collecting data in a systematic fashion, storing it, curating it, making it available. Data has to be cleaned up because a lot of time the data can be junk. So in the case of social good, data is fragmented, it's spotty, meaning it's sparse, it doesn't have everywhere, and it's unreliable, and it's incomplete. Okay, so you won't have everything that you need to know. So creating a culture, a means of creating data in a more systematic fashion, right? And again, the technology platform for doing these things, they have to be cheap, right? You can't deliver solutions to a village on a supercomputer. Nobody is going to use it. You're going to have to deliver it on the cheapest kind of a dual SIM device or something like that. How do we do that? Creating a talent, of people who want to do these things but know the, expertise. Talent is already short in machine learning and AI, but imagine, what percentage of them are actually want to work on the area of social good. But so we certainly want to create opportunities for doing that and partnerships with these organizations. The last one, by the way, is worth mentioning. Many of you must have read articles about the dangers of AI, right? The AI evil. What's the one name of a very famous person that comes to your mind about the evil of AI? Sorry, one by one. What is this? Okay. Elon Musk and Stephen Hawking. Actually, those are the names I was looking for. They have been very, very vocal, right? But they're talking about the mainstream. They're not thinking about the kind of applications I'm thinking about. But even here, there are consequences to doing these kind of things. You all heard about bias in AI systems, right? A machine learns what you teach. If you teach it the wrong thing, it's going to learn the wrong thing. When I say the wrong thing, you just give it some examples that are not really representative, it learned biases. And learning biases, in poor communities, in a caste system-ridden rural India could be the worst thing that we can do. So we need to think about how to control and manage these systems. But then, about it is really the fundamental concepts in AI, various kinds of data science, analytics, natural language processing, vision, graphic, all of that we'll do, and then finally apply it to domains. Initially, we are thinking of focusing on 4 major domains: agriculture, education, healthcare, and public utilities and infrastructure, right? But I mean, they're not, the limitation is arbitrary. One thing that, you may not understand, but few people here, like Ravi and other professors would understand, is that people who are scientists and researchers don't do what they are told. They do what they want to do. So I can't say that, I'm going to get people to work on exactly those things. I always say that if you are someone who's capable of taking direction, you cannot be a researcher, right? So these 2 things are contradictory. You have to, but we're going to create the incentives and opportunities for people to work on the right problems, but I don't know which ones we'll do. Now, so basically, we're going to take a project-based approach, meaning that, it's not research in the sense of professors are doing. It's not fundamental advance of science, but rather applied research to specific use cases. Problems will be drawn from society and solved by science. We focus a lot on deployment. And of course, we'll talk to people in technical forums and tell them what we are doing. That's the best way for me to recruit people. And what we mean by success is really social impact and innovation. We're planning to launch sometime in the middle part of the spring, first quarter of next year. We're going to be based in India. We haven't decided quite yet. I'm looking at Bombay, Delhi, probably here, but more likely in the north. Hyderabad, Bangalore, and so on. And, we'll be a collaboration hub, all areas related to that. Now, let me just say a little bit about the donors. This is really a vision of these 2 gentlemen who I've never met before. They're committing, it's about 200 crores over 10 years. And also, they are both entrepreneurs. They know how to run companies much more than I do. They know what it takes to be actually successful. This is the first time they're working together. Romesh is actually a well-known Silicon Valley entrepreneur. He's made many success. I don't know if it's only 3. He builds companies and sells them. He's also a lot of philanthropy efforts. Actually, he has an organization called Wadhwani Foundation, which is based in Bangalore. They provide training in skilling as well as in entrepreneurship to a large number of people, like about 50, 60,000 people a year worldwide. And he's very well known, well connected in various governments, including the Indian government and things like that. And Sunil, the younger brother, so this is the Wadhwani Foundation, sorry, I already spoke about it. They work in entrepreneurship, skills, and innovation are the 3 major topics. Basically, their idea is to create jobs and allow people to become entrepreneurs, and they teach people how to do that, right? This is nothing to do with our initiative. This is what they've been already doing. But clearly, there is opportunity for me to partner with these programs that they're doing. And Sunil is actually an IIT Madras graduate and a distinguished alumnus, and he's like 3 years more senior to me at IIT Madras. He's famous for a company called iGate, which is, he built and sold about 5-6 years ago. And he's also board of CMU and a number of other places, a well-known philanthropist. His kind of focus has been on something called the Wadhwani Initiative for Sustainable Health. So he's been adopting primary healthcare centers in rural areas. As I was talking to Bhaskar Ramoti today and pointed out, he's primarily focused in the north because, ironically, in Tamil Nadu, these rural healthcare centers are actually run very well. So he's focusing on where they're not run well, which is typically in some of the northern states. And I visited some of them. He's trying to build them up, get them going and create new processes, introduce some technology, teach them the latest know-how and things like that. And, he's got quite a good gig going. And those will be also our partners, right? And they are very receptive to interesting technology innovations, actually. That's basically it. So these are, these people hired me to come and build this. So far, I have 1 employee, namely me. So now in the process of recruiting. One of the reasons, I told Ravi that I wanted to do this is, as we grow, we will be hiring a lot of people. Of course, right now I'm looking for my research leaders, but doesn't let that stop you. If you're interested in working for us, either as an engineer or a research fellow, which means like a researcher before you get your PhD, like you just have to have a BTech, come and work with us. You don't need to have anything else. Or if you have a PhD and you want to do research, if you're a faculty member here, don't read this carefully, otherwise Nagarajan and Bhaskar will beat me up. But you can come and collaborate with us. You can spend a summer, you can spend a few months, and you can partner with us and so forth. Okay, I'll stop and open up for questions. I hope I was not too long. Yeah. Thank you. Now, ultimately, how much you get out of this will depend on how many questions you ask. Okay. So. Yeah. They're brothers. Yeah, they're brothers. Romesh is about 70 and Sunil is about 65 or 66. Yeah. This is the first time they're doing something together, as far as I know. Yeah.
Thank you, sir. Thank you, sir. Are you going to recruit only from people who are from computer science background, or it's
No,
just open
it's a good question. So basically, in order for us to be successful, of course, I'll need a lot of computer science people, data science experience and so on, but domains, right? Healthcare, education, urban infrastructure. So we will require other engineering and non-engineering domain experts to work with us as well. And also policy kind of people, economists and social scientists. So we're not only going to limit ourselves to computer science. However, that said, that'll probably be the significant majority. Otherwise, we won't do any innovation. We are not a think tank, right? We are actually doing tank. But so we do expect, quite a few people who have interdisciplinary approach. In fact, I think if you're a civil engineer trained in data science, that might actually be in some ways, more attractive. Or if you're a, medical specialist trained in data science, that may in some ways even more attractive than a pure computer scientist for us.
Thank you, sir, for nice talk. I have a question. How well it will work for population in India where a lot of diversity exists? So we train for a certain group and then try to apply at different places.
It'll fail.
So, yeah.
Yeah. No, it's a very, very good question, right? See, one of the powers of this kind of technology is its capacity to learn from diverse, kind of examples. So in other words, if your population that you're applying it to is in no way represented in your learning data set or nothing similar to it, chances are, it will fail. However, people have more similarity, even though there may be differences than you think. And second, you don't need a lot of samples from every kind of population, because the common between different segments of population actually usually a lot more than the differences. So the machine learning will learn both the common and the differences, provided we give it the right amount of data. So we have to train it everywhere. And other thing you have to keep in mind is that it's a continuously learning process. So it doesn't have to do right on the first count. And as it fails, you teach it better. So, look, I'm painting a very optimistic view, so keep that in mind. So yeah.
So you made a very important point about data sets being very important in
Right.
driving the success of AI and deep learning, right? So now in this sense, the goal of working on social problems, right?
Yeah.
One characteristic of that is that we work with areas where data is not easily available.
Right.
And to hire people who can create data for those areas is, so my question is, how do you plan to create data sets for working on these problems? Let's say healthcare in rural area, or
Right.
agricultural problems faced by farmers in extreme
Right,
rural
right,
areas, right? So how do you get data for this?
So bootstrapping, right? So that's the classic approach to these kind of things. You start where you have some data, and you start showing the value and instill the culture of creating data, and then you try to spread it around. Take those, methods and put it elsewhere. And one of the, reasons to work with these NGOs and others is that they become the agencies that can help us do that, right?
Okay.
See, data is there. It's just not collected.
Collected,
right? Every time a patient goes to a doctor, they write down a lot of things on these cards. They probably can't read their own handwriting later or something. But nowadays, a lot of it is getting entered digitally. We can facilitate that. A lot of it is on your phone, and a lot of people, have phones everywhere anyway. So it's not that it's not there. It's that there hasn't been an incentive to collect it and store it and use it. And we'll create, once the value is there, we can. That's what we're hoping to do. But it has to be done. It's not like people are going to go around collecting data specifically for this, by the way. That could happen in some cases, but largely tapping into the existing, sort of parts of ways of life, interactions that they have with the kind of people that provide them services to collect data. But one point, I think I'll answer it, ask a question later and answer it since it's not related to this. Okay, but yeah.
I have two questions, so I'll ask both. I think they are interrelated. One is, how far have you progressed in identification and formulation of the problem statements that you're trying to solve?
Right.
And the second is that many of these problems you're talking about, which are societal, right, are kind of complex, interdependent,
Yes.
with socio-economic, political, all kinds of things.
Right.
Pretty systemic problems,
Yes.
not just one-dimensional problems. And AI so far has been, as far as I understand it, are good at solving very specific pattern recognition kind of problems where you like kind of fit a curve to a problem statement or a set of rich set of data. How do you think you can really, how confident are you of saying that these can be problems which can be solved using AI, or it's too early to ask that question because it's still not?
No, it's not. But I think there are some premises in your question that I'm going to challenge. But let me answer the first question first. What was that? How far? Yeah. I'm the only person so far. However, we did do a study about the range of problems, and we did go through a table of potential problems and use cases. So we have a large list. I probably have a list of already 50 to 100 candidate problems. But frankly, it sort of doesn't matter what I have when I hire the team, and they are the ones who are going to select those problems, right? So how far have I gotten? Yeah, we got a lot of ideas. You and I could brainstorm, in 10 minutes we can come out with 50 problems, by the way, and they will all be reasonable. But at the end of the day, when I have a team, that's when it becomes real, okay? But we'll find enough problems. The second point that you mentioned as a certain, presumptions, right? Which is, one of them is, of course it is a complex, interdependent, problem. But it's not as if AI systems don't deal with that kind of complexity. Even something like driving on the road, right, with a has various amounts of complexity, right? The conditions and the behavior and reactions to what you do has huge repercussions. Even something like parallel parking is not, trivial. So that dealing with a complex set of things in itself is not beyond. It's not a beyond scope of AI. It may be, optimization and curve fitting, like you're saying, but there are many curves to be fit in many parts of the problem that are interdependent and who have consequences. Take this reinforcement learning example, right? So I use the word reinforcement learning. What does that mean? See, reinforcement learning is a kind of learning in which you don't know the correct answer, and you may not know the answer correct or wrong immediately after you do something. In a game, you make a move, and the other person makes a move. The failure or success after n moves, 10 moves, right? And then you have to, so machine learning does deal with those kind of complex network interactions and time propagations and as well. However, the reality is this, right? When you have a complex, set of high-level tasks. So let's say, for example, things related to healthcare in a village. There's the person's behavior. There is the attitude of the providers. There is, corrupt officials. There's availability of power and other resources. There's a different level of complexity, right? But you have to start in one place and then go to the another. So yeah, it's typical science. Hold all the variables constant except the one that you want to change, and do that. So ultimately, it's not one time. It's a process of penetrating through this mass. Am I optimistic they can be applied to it? But let me put it this way: if we don't apply it to it, what else do we do? So it's not so much an optimism, but it's more like an opportunity, if you will.
You, in the objective, you mentioned about social change and transformation.
Yeah.
Is that the only way, or abetting and enhancing the existing social structure, something like cost?
Yeah. By the way,
useful?
The word social change and transformation is like very heavy, okay? So don't read too much into it. I'm not thinking about a new form of government or something like that. When I say social change and transformation, simply I think if these technologies begin to become routinely used, it will affect the way of life to some extent, right? A large extent, actually. So cost trade-off itself can have significant, consequences. Just a simple thing, right? 10 years ago, there were not smartphones in villages. Today there is. And the impact that that technology has had on people's life is, non-trivial, quite dramatic. So technology, when it's right and it's able to address certain problems, end up having transformational change. So I didn't mean anything more than that, right? So that's all. We don't have to aim for social change and transformation, but we will get it as a result of, that's all.
Sir, how do you think AI will help in the area of infrastructure? And one more question.
Yeah.
Apart from neural networks,
Yeah.
What do you think about areas like fuzzy logic or
Yeah.
genetic algorithms? Like, how can they help?
Let me take the second question first, okay, because that's sort of, anyway, it doesn't matter. So when I said AI, I didn't mean neural networks alone, right? I was talking about it simply because it's the buzzword of the day and so on. So I come from more of the, graphical models, Bayesian reasoning kind of AI, frankly, myself, which is really not fuzzy logic, but similar to. Fuzzy logic is really logic with a certain amount of uncertainty and so on built into it. Bayesian reasoning, does something similar using a different type of technology. Those kind of systems do have a certain amount of, manual engineering of building rules and so on, and we are certainly not going to stop from doing that, okay? So whatever aspects of AI that work, but when it comes to scale, we do need the power of these network type of techniques and in order to learn faster and in large scale. So it'll be a hybrid thing without any doubt. In terms of infrastructure, right, and this is a very different question, let's just take three types of infrastructure. Utilities, electricity, power grids, the usage of power, right? Every day in Bangalore, in BESCOM, if you go to the BESCOM website, they will announce where you are going to have, where they have power problems. I mean, literally every day there are like 10 postings. And every time power goes in my house, I go to their website, they are promptly able to announce that you lost power and you'll be, power will be lost for another 5 hours, and usually 7 hours, and after that it comes up. Some cable is cut, something or the other. But many of these can be anticipated. Many of these can be planned and anticipated. Typical reaction to weather patterns. So many of these can actually be predicted, right? So we can use a lot of predictive analytics in terms of power. And in India's power is always short. So if somebody is getting power, somebody else is not getting power. And to be able to optimize the, the allocation of power, handling, contingencies, we can help there. You take road networks, right? Traffic management. We have a lot to do there. I don't even have to say it because most of the time, the jams and the congestions are quite predictable. Today, of course, we use Google Maps to probably find it, already, but how do we use that to enforce control? Somebody was telling me about traffic prediction and the traffic police who arbitrarily takes their time to change the light. This thing can be optimized, for example, right? Similarly, railways, shipping, any of those kind of things, water resources, allocation. See, anytime there is a natural resource or a man-made resource that is a public kind of a utility, there is the burden of having to share it. There is the burden of having to, when I say burden, I mean you have to solve the problem. There is the problem of having to deal with contingencies that you cannot anticipate. And there is, method of payment that, may be variable. Many of these problems are very analytic problems that can be solved, right? So, yeah.
At the beginning of the talk, you did mention that AI for social causes has not been there because money is not there. So
Yes.
eventually, you will also have to address the problem sustainably.
Good question. That was a question I was going to ask and answer myself, which is that in the long run, by the way, there is a fallacy in this, that if everything we do is ultimately provided free through donations and charities and government services, it actually will not sustain itself for the long time. Then there's a simple reason. Money runs out, economy changes, governments change and their policy and priorities change, societies fragment. So in the long run, the things that you will see in society that actually are viable have a self-sustaining commercial model, right? Without a self-sustaining economic commercial model, it's not going to be there. Now, right at the moment, I'm in no position to think about those kind of things, but we will certainly be, looking at solutions that have the capacity to sustain themselves, right? First things first, we have to crawl before we walk. But I think this is what point I was, going to bring at myself, is that there is one thing that I didn't address, which is going beyond, the feasibility and scale deployment. How do we get it out of the dole system and into a more, self-sustaining payment? I don't know the answer to that, but that's something that will, come up later. But that's certainly important for us to do, right? And one thing to this extent is that we will be creating a lot of IP, and we will be looking to create, and give it to people who have the ideas of making businesses out of it and things like that. I don't mean give it for free, but we'll do something, right? So, but those are a little bit, further ahead. Yeah. Thanks for that question. Yeah, students usually don't think of those questions because I think must be that parents are paying their bills or something, whatever. So, what? He was a student. He's no longer a student. Are you a student? You don't look. I mean, he looks like he's a grown-up person or something. So. We would love to see you do it. Yes, the answer is. But as a part of, remember, talent development is something, one of our foundations. We have to do that, right? But that in itself is not the end goal. It's an enabler for the greater innovation chain, right? Just like data set collection. It's a necessity and a requirement. So I reduced teaching to data set collection, if you notice. But okay, well, thank you all for the time, and hopefully I'll come back to you with some reports down the line on how we do. Yeah.
Thank you so much for the lecture, sir. Now I'd like to invite Dean Nagarajan, sir, to give him a token of gratitude.